Thank you and welcome to the last but hopefully very interesting session of today. I'm KP. I'm a senior GTM specialist for APJ data and very happy to co-present today together with my colleague Joel Garcia on how to handle your data in modern microservices architecture. Let me start by asking a very interesting question. How many of you have actually played Pokemon Go, the mobile game? Fantastic. Even if some of you have not played, I think you must have heard about it when it was launched. So the Pokemon, the company, actually was famous even before that. In 1996 in Japan, when they started introducing the card game, the Pokemon characters become very popular. But in 2016, when company actually launched their Pokemon Go game, they faced very different kind of challenges. In a span of 2 years, the user base for that particular application grew to 300 million users. And the requests were not just coming from one particular region or geography, but they were coming across the globe. So the company faced some unique challenges and they have to rethink about how to re-architect their applications, how to look at management and maintenance of the software and application. And they started their modernization journey. And of course, they started looking at cloud model, leveraged AWS purpose-built databases in their whole modernization journey to cater to the challenges. But what actually this Pokemon, the company, faced at that point was not something unique to that particular mobile game or application, but it is a challenge that is faced by many organizations today in building the modern microservices architectures or even the modern applications today, which we call as internet scale applications. So when the volume, variety, and velocity of data that is being coming to these all modern applications, they are faced with some very unique challenges, like handling millions and millions of users, millions of requests per second that they need to handle, handling the data from petabytes to exabyte scale. And while doing all this scalability, they also need to make sure that they meet the requirements of performance, sometimes microsecond latency or millisecond latency. Now, organizations are not yet ready to invest upfront in these scalable solutions. They want to see how the particular application is performing. They don't know which is growing exponentially or which is going to grow linearly. So they want to make sure that they invest into the technology and the business applications at the right time. And that's why they are looking for pay-as-you-go models or having that flexibility in terms of payment or investments. Now, the data that is generated or being consumed by these modern applications, it is not just getting limited to that particular application. It is getting leveraged across the organization, and at the same time, it is being leveraged by multiple other collaborative organizations through API mechanism. So if we think from the development perspective, these are some unique challenges that are faced by all the modern applications, right? And what are they? So if these kind of scalability, performance, global access, all the challenges are considered, a three-tiered, tightly coupled architecture, which is a very traditional architecture of presentation layer, then you have business logic in the middle layer, and then you have database, which is a very tightly coupled architecture, doesn't suffice. So, and that's why we have modern architectures like microservices, where business logic is actually moving into each of these microservices. And these microservices can now scale in, scale out as per the requirements of that particular application and that particular microservice. Now, the beauty of this architecture is each microservice can now have a different access to the data storage layer, either through queues or caching and messaging mechanism. And that means each of these microservices can ideally leverage a different data store which is purpose-built and suitable for that particular microservice. What do I mean? For example, if a particular microservice is handling transactional workload, it can go back and handle or put the data in a very traditional relational database. Whereas if you have a microservice which is handling like a recommendation engine kind of service, it can go back and connect to a key value pair kind of database. So depending on the nature of the microservice, you can have a different data store. And that's the beauty of a loosely coupled architecture. So if I have to compare and give it like an analogy to you in a more simplistic way, the traditional architectures are like spaghetti, where everything is intermixed, the sauce, the noodles. You really cannot separate out the components. But the microservices architectures can be like a ravioli pasta, where each ravioli, in principle, can contain different components. It can be self-contained, and you can have different variety of flavors in each ravioli, in principle. So now, if we look at the benefits of all these microservices, you have continuous development and deployment. You can do that with smaller team size. You have better maintainability of your code, fault tolerance. All these benefits are there, yes. But the one important benefit that microservices architecture provide you is the business agility. The whole purpose of having these modern architectures is basically providing that access to the business and basically making sure that the business agility is built into your applications. Whenever the business needs change, you need to make sure that your applications are also changing with the pace. You need to make sure that time to market is faster. And this actually leads, this whole modernization journey actually leads to a very virtuous cycle, kind of a flywheel effect, where if an organization is making sure that there is an alignment with the business needs, it actually leads to empowering your teams, where each team can then focus on its own microservice that they're building, making sure that they use the right technology stack for that particular microservice, which in turn leads to a proper interfacing for their data governance and making sure that there are different data contracts in place. So on one side, you have business transformation, which leads to a technology transformation, and that again feeds to a business transformation, making sure that there is a perfect alignment with the business for the technology. So this virtuous cycle is there, and that's actually this pursuit of modernization has led many organizations to search the right ideal data store, right ideal database, which meets all these 6 characteristics of a modern data store. You need to have innovation, agility, performance, scalability, cost effectiveness, and at the same time, it should be easy to manage, if at all such a database exists. But as you all can imagine, this does not exist. Even the most popular multimodal database today has to live with some kind of trade-off, right? And that's why if you go back and look at your app infrastructure, you will end up having multiple databases today, multiple data stores today, right from your relational databases, non-relational databases. Some of them are self-managed, some of them are managed by vendors, some of them are on the cloud. So if we look very closely at all this plethora of databases and data stores, actually it's not that complicated. There are some very few access patterns that emerge through this plethora of database or data store solutions. The most common being the relational databases that we all know. But there are key value stores, there are wide column databases, there are connected data states, you have ledger databases, and these very particular hand-picked data access patterns that emerge. But the main challenge happens when an organization or you need to manage this plethora and this kind of data stores and diverse kind of skill sets within the organization. You have to live with it, you have to manage, maintain, install, configure, patch, upgrade. You have to do it everything by yourself, and that's become quite challenging. And that's where organizations struggle to take their first steps in the modernization, right? Thankfully, AWS is there to help you in this journey. AWS offers the broadest set of purpose-built databases, including relational as well as non-relational databases. And all the maintenance, management, patching, upgrade, everything can be taken care by AWS, whereas you as a customer can focus more on the differentiated workload, more on the schema design, application design, performance fine-tuning, and all such very differentiated work, which really matters to your customer, leaving aside all the heavy lifting to AWS. Moreover, you don't need to worry about under-provisioning or over-provisioning your infrastructure, because all that can be taken care by AWS. You also don't need to worry about investing upfront in the technology, because you have the flexibility of pay-as-you-go model, on-demand pricing. So all these benefits are there so that you as a customer can focus on innovation and modern application development, leaving aside all the management and maintenance of all these diverse databases to AWS. Now, as you understand, this all modernization journey is like a flywheel effect. The natural question comes, where do we start, right? And to help you, take you through this journey, I would like to invite Joel Garcia. Now, Joel is head of technology for ASEAN. He and his team of solution architects actually helps a lot of customers in this database modernization journey. So to take you through these next steps, I would like to call upon Joel on stage.
Thanks, KP. So good afternoon, everyone. We're in the home stretch. So, thank you, KP, for actually setting the tone and the context, right? So you've seen a lot of presentations today, especially in terms of modernization, where there's a move towards this microservices architecture. Well, this is sort of like the inseparable twin, right? When you think about how you're modernizing your applications, you're also going to be modernizing your database, right? But where do you start? And a lot of customers usually ask, where do you start? Well, first of all, you take one step at a time, right? It's like a journey, right? It doesn't happen overnight, and clearly we'll kind of take you through what those steps look like today. I've spent some time actually managing and deploying these large relational databases in the past. And this is where it kind of starts, right? Usually you kind of start out with the RDBMS. Not always, but usually it ends up starting here, right? And similar to the way with the strangler pattern, right? It's almost like, well, where do you start in actually breaking this down, right? In terms of these modernization of these existing applications, right? But it isn't just about modernizing this RDBMS. It's also the story, the fact that these businesses and requirements of how we serve our customers have changed, right? It's about the story about startups and building new applications, or being able to deploy, for example, rapid prototyping, or maybe with developers that are using tools like ORMs or ODMs and abstracting that database layer, right? So you need more modern database options. Let's take our first step. The first step could be where you just move your existing RDBMS platform to a managed database solution. And we offer several options there with Amazon RDS and Amazon Aurora, right? For our customers that actually move to this managed database offering, we help them kind of get rid of this, what we like to call undifferentiated heavy lifting, right? Where they don't have to worry about the day-to-day operations about managing their database, because then they can take their efforts and focus more on what matters for the business. A great example here is actually Amdocs, where they're leveraging our managed database service, and in the process actually breaking away from their commercial legacy database as well. But they had two challenges that they needed to face. One is they were looking for a solution that was going to provide flexibility for their Revenue One application, right? That would need to be able to respond to a lot of the new 5G services and applications that they were deploying. The second challenge that they were facing is that usually it would take up to 3 weeks for them to be able to deploy a database cluster, right? Clearly, they needed to be a little bit more agile. When they moved to Amazon Aurora, they were able to address the scalability requirements for the business, where they could provision and deploy faster to support these 5G services. They also reduced their operational overhead, right? Because they moved to a managed database offering. But here's the interesting thing. They're actually able to save costs. They're actually able to reduce their licensing costs by moving to a pay-as-you-go model rather than your traditional licensing model for their database. Now, as we kind of go on, that's the first step, right? Moving to a managed database service. The second step could be, right, moving and leveraging, for example, cache and persistent in-memory data. And what that means is you can kind of think about that the way that web applications are deployed today, right? There's usually a caching layer in front of a web application because usually you get thousands, even millions of requests, right, for web applications. It's the same pattern for putting a cache in front of a relational database, right? We kind of offload the relational database and cache a lot of that information to deliver this sub-millisecond database access, right? And we have, again, multiple offerings in that area. We've got Amazon Elasticache, and we have Amazon MemoryDB, right? Now, I got an email this morning that kind of reminded me that Mother's Day was coming up, and whether or not I actually wanted, as a reminder, to send a gift to my mom. And that was actually an email from Lalamove, right? So Lalamove is a delivery solution and a classic regional success story. I use Lalamove a lot because if I go biking and I decide to bum out, I use the Lalamove service to actually send my bike over and send it home while I go and enjoy my white coffee somewhere, right? But I'm one of those guys that frequently checks the status, right, of whether or not my beautiful bike has made it home safely, right? And as a result, Lalamove actually uses Amazon Elasticache to deliver that low latency status and driver matching so that I get that information almost instantaneously when I'm querying. But in the process, we all know that these demands can spike. And in the case of Lalamove, and when everyone else decides to send their bike home maybe, right, there are also spikes obviously in their demand. And by using Amazon Aurora, we help Lalamove also address their requirements of addressing traffic spikes up to 400%. But there are other benefits because Lalamove is using Amazon Aurora. Amazon Aurora actually gets deployed to what we like to call our 3 availability zones. So in the event of any instance failure whatsoever, right, Lalamove can have recovery in less than 30 seconds by using Amazon Aurora. Now, as we kind of move forward, that was the easy part, right? We could move to a managed database service and actually put caching in front of the RDBMS. But as we kind of look at really adopting more, and as you've heard about some of the patterns about making the monolith at the application layer, right? This is breaking the monolith at the data layer, right? So you'll have options and the right tool for the job, right? Whether or not, for example, your microservices architecture requires a key value pair, we have Amazon DynamoDB. If your application requires to be able to handle document types, then we'll have Amazon DocumentDB. And if your microservices architecture requires you to, for example, leverage Apache Cassandra into a managed offering, we have Amazon Key Spaces. The fourth step is when you actually move beyond that, there are even more specialized data interactions. So for example, in ASEAN, I'd like to say, and we all know that we're probably one of the most socially engaged, right, regions in the world, right? And as a result, for example, if customers are looking at how do you map all of those social relationships, we have an offering called Amazon Neptune. If there's a requirement where, which we have a lot of customers that are leveraging, for example, the Internet of Things, where they potentially have millions of sensors, right? Potentially millions of sensors, collecting all of that information where you need to do more time series type of analysis. We have something called Amazon TimeStream. And for those highly regulated industries where you might have to record things like system of record or having an immutable ledger of some type, then we have our offering, which is actually our Amazon, and I love the name, Quantum Ledger Database, QLDB, right? For those type of requirements. Now, a great example here is Dream 11, right? And Dream 11 is a fantasy sports platform offering from India. And they're highly successful, but the way that they kind of differentiate their offering is by by creating these really rich social interactions where they do public as well as private contests. Sorry. And what they actually map, now imagine mapping all of those social relationships, right? They're actually able to map and they leverage Amazon Neptune by graphing those social relationships, leveraging 20 million nodes and having 200 million edges, right? Hand in hand in conjunction, they're also using Amazon Elasticache, because you can imagine, as users are actually kind of interacting on the platform, you will need to deliver that sub-millisecond response, right? Which Amazon Elasticache delivers. Now, as we kind of look at step 1, 2, 3, 4, you're probably wondering, okay, what's the next steps after that? Well, usually, in most cases, our customers will look at, and we know that the customer demand signals are always changing, right? The requirements of these new customer experiences we're creating. So the next steps are, what we see with customers is they end up unifying and eventually getting the insight, unifying the data, building the insight from that data, and then applying and creating new experiences to innovate. Now, when we look beyond the transactional application needs, right, companies will eventually build a business-wide sort of like data platform or data unification strategy. We're not going to go into that today, but that usually involves building one or two, and you've heard it, building one or two data lakes, right, where they are unifying that data, getting the insight, and applying things like machine learning, maybe to do things like predictive analytics to understand how they can serve customers better. Now, to sum it all up, and we only have a short period of time, hopefully you've seen enough, is obviously depending on where you're starting, right? Whether you move to a managed database offering, or eventually you're looking at specialized data sets, right? AWS offers the widest, right, offering of managed database services, whether it's relational or non-relational, right? And as a result, right, you can go to this page to actually access more information on a lot of our purpose-built databases that you can go and leverage the right tool for the job, right, in the way that you're modernizing your microservices architecture. And as a reminder, consistent as you look towards upskilling, you can engage our training and certification offering, where we have over 600 free digital courses on skillbuilder.aws. We hope that you've enjoyed the session today. We hope that you found this fruitful. Please, as a reminder, please complete the survey when you can, and enjoy the rest of the evening. Thank you.